thinking about how we decide who has more of something. How do you normally figure that out? There are lots of instances in your life when you need to figure out who's done something more, who has more. How do you normally do that? Nathan, how do you normally decide who has more? So how do you decide? Okay, so if we split a cookie in half, how do you decide who has more?
What's the title?
How do we decide who has more? It's kind of a weird thing to think about, Marley. Okay, but what if I am not splitting something in half and someone is getting more? How would I decide that? Okay, Lydia?
Like, for example, let's say you and your friend are trying to see who spent more hours outside. You would set a timer or something, or like a stopwatch to see who spent more time outside.
Okay, so in Lydia's example, she's saying, okay, what if we're trying to decide who spent more time outside? Lydia's using a timer. How would you know with that timer who spent more outside?
Like, if the hour, like if one friend had 1 hour and the other friend had 3 hours, you would know the person with 3 hours had more time.
How do you know that?
Because 3 hours is more than 1 hour.
Okay, so we're looking for things like a larger number. If we go back to Mason's example, even if we split something in half, chances are it's not completely equal. How do you decide who gets more? If it's not exactly in half, what do you mean? If it's not exactly in half, you've split something up, how might you look at that and say, oh, that's unequal, one of you gets more? What are you looking for? Art?
You're looking for, like, who has the greater length.
Ooh, so Art used the terms greater length. When I think of splitting up a cookie, you know what I'm looking for? It's very similar to Art's, just not as nicely said. I'm looking for the bigger piece. So depending on what I'm trying to figure out, who's got more, I might look for the bigger piece. If it's something long, like maybe pants, who's got longer pants, I might look at length. If I'm doing something where I'm timing someone, like in Lydia's example, I might be looking for the larger number, probably seconds or hours or whatever my measurement is, but I'm looking for who has the larger amount of that number. A greater amount or stuff. So if I'm doing this race and I'm trying to prove to my friend that I ran more, if we were running at the same time and I kept running, that would be easy. But what if I ran at a different place? Do you see what I'm saying? I love what Matt's saying. He's saying, okay, well, if you ran together, obviously the person who ran 3 miles would run farther. They would see that. Paxton's got a book open. But what if we ran at different places? How might you prove it? Art, what do you think?
Whichever place has, like, whichever place is greater than the other place, that would have
All right, so I'm hearing length again, which is a really good spot to be because we're definitely measuring miles. Miles are length. Mason, what you thinking?
How do you prove it?
Mm-hmm.
Well, 3 is a greater value than 2. And then, who started running first?
Is that gonna matter?
No.
If they're running at different places, does it matter if I ran in the morning and my friend ran in the afternoon?
No. Yeah.
Is it gonna affect who ran more?
No. Yeah, because it might be hotter. Temperatures.
Well, if I run 3 miles in the morning and they run 2 miles in the afternoon, does it matter that I ran in the morning? Is that why I ran more?
No.
Probably not. Connor, what are your thoughts?
Maybe you can prove it by, like, since we're doing, like, maybe you can draw, maybe you can draw, like, a line at, like, the start, and, like, you can do laps around the place, and you can do, like, more and more, and then, or maybe if you have, like a little watch thing, you can see how many steps you do.
I love the idea of a line. Draw a line in your notebook. Pink line to pink line. We're going to just draw a line in our notebook. I'm going to put an M next to it. That M stands for Miss Miller. This is Miss Miller's distance. When you start a race or you start running, what mile are you at? You're at 0. So I started at mile 0. I had run 0. How far did I run? Jordan?
In all, you ran 3.
I ran 3 miles. So I'm going to put 3 at the other end. 3 miles. I'm also going to put the other distances that I ran. If I ran 3 miles, did I run 2 miles?
Yes.
If I ran 3 miles, did I run 1 mile?
Yes.
Yes, I had to pass that. So I've got my 1 mile about there, and I've got my 2 miles about there. Notice, Connor, that I have equal spaces on my lines. Why? Why do I have equal spaces on in between my lines?
Because it's gonna be kind of weird. If you have a mile that's like this long, and then you have a mile that's this long, this one is not gonna be a.
Let me tell you, if I got miles that are this long, I'm running a marathon. Because that looks way shorter than if I got miles this long. Right? Yeah, a mile is the same distance. Whether it's here, or here, or here. I'm not going to have a mini mile. That would be really cool. As a runner, I would love a mini mile. But we don't have mini miles. We just have regular miles.
A mile like this long.
I know, that would be really cool.
A mini mile.
Now, I have so far proven that Miss Miller ran from 0 all the way to 3. I've got Miss Miller's mapped out. But I need to prove it as being more than my friend. So I'm going to draw another line because she also or he also ran. And I'm going to make it the same distance. Now remember, this is important. You remember a couple days ago when we were comparing pizzas?
Pizza.
And someone had a small pizza and someone had a really big pizza? Could you compare that very well? Even though they both ate 2 pieces, did they eat the same amount of pizza? No. So we need to make sure that our distances are the same. Put your hand down for a second. Great. I'm going to put an F next to this line. F stands for friend. Now my friend also started where? At 0.
So put it
But like Connor was saying, is my friend's mile worth the same distance as my mile?
Yeah.
Do they have shorter miles? Do they have longer miles?
No, they have the same length miles.
They have the same length mile. So a same mile that I run is the same mile that my friend runs, right? It's the same distance. Yeah. So here's my 1 mile. I made it the same distance. Because 1 mile for me is the same as 1 mile for Addison. It's the same as 1 mile for Brogan. It's all the same distance. You just might not run as far. Did she run 1 mile? No.
No. She ran 2.
So let's put our 2 down. Notice I'm putting my 2 at the same spot. Someone raise your hand and tell me, why did I put my 2 at the exact same spot? Archer, why did I put the 2s at the exact same spot?
Because it's still the same length. They're not it doesn't mean your friends ran that. It's the miles are the same length because they're both miles.
Yeah, my unit is the same. I'm still counting miles. There's just different amounts of miles. Yeah, beautiful. Ava, what's that?
Also, at one point they were at the same area, but then one maybe got tired and they stopped for a minute, then the other one.
Definitely true. So my friends started at 0. They definitely ran 1 mile, and they ran all the way to 2. In this model, go for it.
Well, I think she ran more. You ran more miles than her, because even if her track might have been longer, it's still a mile. It's still a mile. A mile is a mile for both of you is the same length.
Yep.
So
Absolutely.
even if she had a different track that's bigger, a mile would be the same thing for both of you.
Yep, that's why it's really important that we counted the same unit, right? It's kind of going back to that pizza. If we're comparing who ate more pizza, but you ate a tiny pizza, and I ate extra large pizza, and I said, okay, Addison, I ate 2 pieces, and Addison's like, cool, I ate 16. That's not really a fair comparison because she ate mini pizza. That's all I'm saying. Yeah, definitely true. On this model that we just drew, how do you know who ran more? How does that picture prove it? We drew that picture to prove it, so how does that picture prove it? Maverick, how does that picture prove that Miss Miller ran more?
Because you can look on the board that your friend, so basically you ran all the way to 3, and your friend ran all the way to 2, and you can see you ran 1 more mile than them.
Yeah, that distance, going back to what Arik said, I've got a greater length. It goes farther across than this one. What's up, Lydia?
So I was gonna say something.
Go for it.
Let's say so your track is only 1 mile long and you do it 3 times, and her track is 2 miles long. It's you guys still ran the same miles except you just did your track multiple times.
Definitely true. Brogan.
I'm confused because wouldn't we just your friend ran 2 miles, so I got confused because why didn't we put a 1 in the middle of there? We would have had 1, 2.
Brogan wants to know. I'm going to draw this in red. This is a fantastic question, but I don't want you to write it down. Cole, is that yours?
What?
That desk?
No.
Then don't destroy it. Brogan wants to know, okay, why didn't we draw our number line like this? Which is a really good question. Why did we not draw our number line like that? Because our friend did run 2 miles. Tough one. Connor, what do you think? Why did we not draw it like that?
If you drew it like that, the one. So if you drew the one for the 1 point, the other mile will be way too long. But if you drew it in the middle, then that would be the same as your.
Jackson, you want to add on to Connor?
so your miles would be short, so you could run more miles, and then your friend's miles would be longer, so she could only run shorter miles.
Rogan, do you remember when we talked about the line of equality? And we talked about how if things are exactly the same length, they're worth the same amount. When I put my arms up here, are they the same length? They're the same distance though, right? But is 3 miles worth the same as 2 miles? Do you see the problem? And then what Paxton and Connor are saying is, okay, well, when I put my mile down, you're saying that her mile is this big, but my mile was only this big. Is that fair?
No.
Does that even happen?
No.
Are there 2 different size miles?
No.
No. So that is why, Brogan, and brilliant for those who figured that out, that's why we didn't draw it like this. Because we know that 2 miles isn't equal to 3 miles. Right? Yeah. Fantastic. Lydia,
I was gonna add on.
go for it.
So let's like for like the size on each side for the thing written in red, it's like basically like a mile and like a yard. It's not the same as your mile.
Yeah, it's not the same distance. And that doesn't make sense,
Hers
right?
would also probably be 3 miles because they're like bigger and then yours are like tiny, but they probably are worth the same.
We would end up at the same total, yeah. All right, Mason, what's up, friend? Talked a lot about how I ran 3 whole miles, she ran 2 whole miles. I'm going to present this last thought. What if I hadn't run a mile yet? Let's say instead of running 3 miles, maybe I only ran
2 miles.
No, let me explain my story, please. Instead of running 3 miles, maybe I only ran like half a mile. I didn't even get to 1 whole mile yet. Half of a mile. So instead of running an entire mile, I ran half of it.
How long is a mile?
A long way. So instead of running a whole mile, I only ran part of that.
4 miles is not that long.
Okay? Could I still compare? Jordan, you seem very adamant. You're saying yes, absolutely. What are your thoughts?
Yes, you can, because it doesn't matter if it's whole or not. It's a whole mile because it's still a number. It's a fraction.
Yeah, so instead of saying I ran a whole mile, I have the power, Paxton, to say, oh, I know how to write that as part of a mile. It's a fraction. I can say, well, instead of running a whole mile, I ran this part of a mile. And that's what we're going to talk about today. We're going to talk about how do I compare my fractions. All right, so let's look at this problem. It doesn't have all the information. We're going to be doing some thinking and some wondering. Oh, so it says Charlotte and Jason are both reading a book. Charlotte says she has read 2/3 of her book. Jason says he's read some of his book. What are some things that you're wondering? What are some things that you're wondering? Marley, what are you wondering? We probably need to know how much Jason has read. What else are you wondering? Brogan, what are you wondering?
I'm wondering how many Charlotte read.
Well, I know that she's read 2/3 of her book.
I'm wondering, how many Jason read.
Okay, maybe we're wondering how much of Jason's book has he read? Paxton, what are you wondering?
How many pages on the book?
How many pages are in each book? That might be important, right? If Charlotte is reading this book and Jason's reading Harry Potter, that might be very different, wouldn't it? Yeah, important things to think about. about? Lydia, what are you wondering?
I was wondering, like, how big each book is.
How big each book is. Bowen, what are you wondering?
How much words each book has.
How many words? You might have seen books have different size fonts. Some books have really tiny fonts. There'd be a ton of words. And some books have really big font. Maybe there's only like 4 words on a page. Definitely true. Jordan, what are you wondering? Maybe what are the books called? Callie, what are you wondering?
What type of book?
Maybe what type of book? Sure. Emma, what are you wondering?
How long the book is?
Yeah, that might be important. I'm going to give you some more information. Charlotte and Jason are both reading Wonder. It's a really good book if you haven't read that one.
What is?
It's a book called Wonder.
Yeah.
They're both reading a book called Wonder.
My sister.
Charlotte says she has read 2/3 of her book. Jason says he has read some of his book.
So how much?
What are we wondering now? Because we did get some information. Addison?
I'm wondering what the sum.
I'm wondering what the sum is too. Maverick, what are you wondering?
I'm wondering, like why, like, there's only 3 pages.
It doesn't say that she's read 3 pages. It says she's read 2/3 of the book. So if I think that's not what it means, if I think of my whole book, she's read 2 of 3 parts of that book. So if the whole book is split up into 3 parts, she's read 2 of them. Does that make sense? It's not 2 pages. 2/3 of the whole thing.
That's 3 parts.
Okay? Paxton, what are you wondering?
How many pages on one day?
Still might be interesting to know how many pages. Even though they're reading the same book, might be interesting to know. All right, what are you wondering?
I'm wondering how big the book is.
Yeah, how big is Wonder? Jordan, what are you wondering? How many chapters are in Wonder? Emma, what are you wondering?
I'm wondering if one of them like read some of their books and stopped because they got really bored.
Yeah, I'm wondering, are they still reading? Maybe one of them is stopped, and one of them's still reading. Archer, what are you wondering?
I'm wondering if Wonder even has chapters.
It does have chapters, but yeah, it's a good wonder. Julian? Okay. I'm going to give you some more information. Charlotte and Jason are both reading Wonder. Charlotte says she has read 2/3 of her book. Jason says he has read 2/4 of his book. Who has read more of the book? I know. What are we trying to figure out? I'm not asking what's the answer. I'm trying to say, what are we trying to solve? What's the unit I'm counting? What am I figuring out? Marley, what am I figuring out?
Who has read more?
Who has read more of the book? Have either of them read the whole thing?
No.
So the answer is not going to be one whole. They've not read the whole thing. They've only read part of it. I'm writing, that means you are writing. Blank has read more.
Blake has read more.
We just know from Marley, we got to figure out who's reading more. That's the whole point of this. Blank has read more. Callie?
Is Wonder a chapter book?
Wonder is a chapter book, and it is in the library if you are interested. It's a super good read, and there's a movie. That is also really good. But it'll make you cry. I definitely cried reading Wonder.
Why?
You can read it. Is it Wonder? I don't know if I have Wonder actually, but I absolutely know it is in the Dixon Library. All right, let's start. We are going to be comparing the amount they have read. With drawing our model, is our model going to be the same size?
Yes, yes. Because they're both
reading the same book. Yeah.
They are reading the same book. We're going to assume it's the exact same. So I'm going to draw a C, and I'm going to draw my big old bar. There's my really long book for Charlotte. And then I'm going to make that next bar the exact same size because it's not commutative property, it's equivalence because it's the same book. And I'm going to put a J beside of it. So again, I made those two models exactly the same size because it's the exact same book. Now, have they read the same amount of that book? Probably not. So let's look at Charlotte. Charlotte has read 2/3 of her book. What is that going to look like? How do I show that Charlotte has read 2/3, Callie, I need you to focus, please, of her book? That's not many hands. Get out of Avaland and back into Snowder's world, please. How do I show that Charlotte has read 2/3 of the book? Brogan, what are you thinking?
We could draw a line in the middle
Why am I going to draw a line in the middle?
to represent the two parts of the book she read.
Okay, so we know she's read 2 parts, but how many parts did she break her book into? So we need to break this book into 3 parts. Let's break her book into 3 sections. Why did we break her book into 3 sections? Callie, why did we break her book into 3 sections?
because she read 3.
Look at that fraction. You're right. This information comes from our fraction. Why did we break this bar into 3 sections? Julian?
Oh, because there's 3 pages of her book.
Not 3 pages. Not 3 pages. All right, get out of arts land. Connor, why did I break this into 3 sections?
Because she read 3.
Well, why did I break this into 3 sections?
Because she read 2/3 of it.
Okay, so why did I break it into 3 sections?
Can you show the thirds?
I need to show the thirds. That denominator, I'm going to write it over here, of 3 tells me, okay, she broke it into 3 sections. And of those 3 sections, how many did she actually read? Colby, how many did she actually read? She actually read 2. Now, I can color in any of these 2, but just to make it easy, I'm just going to color in the first 2. All right, so we've got Charlotte done. Now we gotta look at Jason. Our problem said that Jason read 2/4 of his book. How am I gonna break up his book? Callie, what you thinking?
You can go like the window.
Okay, I'm not gonna draw a window for this one because it's gonna be harder for me to see. But keep thinking of that. What am I going to break this into?
You can draw lines going up.
Let's give me a numerical option. A number. how many parts. How many sections am I gonna break Jason's version up into? Broken up. I'm gonna do it into 4. Yeah, 4 sections. I'm gonna break it the same style, though, Callie, as Charlotte. Can I do a window to show 4? Sure, but that makes it harder for my brain to see who has more. So I'm gonna use the same style of breaking it up and down like this. Does that make sense? Cole, you got that? No. Cole, knock it off. Now Jason read 2/4. So far I just got his 4 sections. Of those 4 sections, how many did he read? It's not a trick question. Julian? 2. Just like Charlotte, I'm going to just color in the first 2 because that makes it easier to tell who read more. Now we've got our model. Can you tell who read more?
They read the same amount of
Is it a tie?
no.
You're right. They both read 2 sections. Bowen, is it a tie?
No,
How do you know that?
because in fractions, the littler,
Use my
the
picture to explain.
denominator,
Use my picture to explain.
Charlotte has more.
How do you know? What do you mean she has more? Because she has 2 pieces and Jason has 2 pieces.
But it's broken up into 3 different pieces.
Yes, friends. Look at Charlotte's sections. They're way bigger. So you're right, Archer. They both read 2 sections. But Jason's are smaller. Do you see how his distance is smaller than Charlotte's distance? You see that? Yeah. So, did they read the same amount of sections?
No.
Listen to my question. Did they read the same amount of sections?
Yes.
Yes. But were the sections the same size?
No.
No. So, raise your hand. Who read more? Tell me who read more. Charlotte read more. Now, back to what Bowen was saying. If I look at my 2 fractions, Jason has the biggest digit. He's got a 4 in it. How come Jason didn't read more? So again, Charlotte read 2/3. Jason read 2/4. That's my biggest digit right there is a 4. So how come Jason didn't read more? He's got the biggest number in there. Cole, what are you thinking?
Probably because each time you go higher, it gets smaller.
You need a little bit more words in there, but yes, let's be more specific. Each time what gets higher?
Denominator.
Okay? Every time our denominator gets bigger,
And the I forgot what it's called. Numerator.
The numerator does what?
Gets smaller.
Nope, that's not true. Bowen, you want to help him out? Cole's on the right track. He's just got his words mixed up.
Every time you make the number bigger.
All right, pause. Bowen is looking up here at my fraction pieces. This is probably going to be helpful when we start thinking about sizing. Go ahead, Bowen. Keep going.
Every time the numbers get bigger,
The what gets bigger?
the denominator gets bigger, you have the same amount of thing altogether, but you have to split it smaller because they're bigger.
Beautiful. Air high five coming at your face. Yes, friend. Well said. Look at my pieces. When I have a bigger denominator, that means I have to cut it up into more pieces. Look at all these 16ths. How many 16ths do I have here? 16 of them. Look how tiny they are.
They're so tiny.
Compare that to my third. 3. But 16's a bigger number. How did that happen? 16's a big number, but look how gigantic a third is. How did that happen? Lydia?
Because you had to cut the 16th into 16 pieces. So they're gonna have to be smaller. You can't make like giant 16.
Exactly. When I cut up that 16, I had to cut it into itty bitty pieces to make 16 of them. I didn't have to cut as many to make 3. Beautiful. Maverick, what's up, friend?
So basically, Charlotte read like 2 of these. And
Yeah, go ahead and grab them. You can stand on the table if you need to. Just put
Charlotte,
them on the. Go ahead and pull them and put them on the board so we can see it.
are those magnets?
Yeah.
So,
That'll work.
it was like,
Charlotte read 2/3 versus 2/4. Check that out.
you needed like another 4.
So- Yeah, she needed just a little bit more. It looks like how much more?
Like 1/6.
1/6 maybe. Probably more than 1/8, but maybe a couple of 8s could fill in that.
2 1/8. 2 1/8.
Yeah, we needed a little bit more. We just needed to read a little bit more to get to the same amount as Charlotte. You can leave them up there. Awesome job, guys.